Alrighty, for these 8 integration problems, they are general antiderivatives that we're looking for, not definite integrals. So we're going to have a plus c at the end of each of them. So let's start with this first one, number 7. We integrate 4x to be 2x squared, so I went up a degree and divided by the new degree, plus 7x plus c. That one was just a polynomial, so pretty easy to antidifferentiate. For 8, e to the x integrates to itself, and the constant just stays. So I have 5e to the x. X goes to x squared over 2, and then 1 over rad x, which was really x to the negative 1/2, that integrates to x to the positive 1/2, and then when I divide by 1/2, that's really like multiplying by 2. Then I have a plus c. So for 9, I will rewrite this as x to the 3/2 plus x to the negative 3/2. That's what I'm integrating here. So I'm going to go up a degree to x to the 5/2, and when I divide by 5/2, I multiply by 2/5. Then on the next one, I go up a degree to x to the negative 1/2, and when I divide by negative 1/2, it's really like multiplying by negative 2, and then I add a plus c. Now this next one, cosine of 2x, I need to use a half-angle formula for the cosine of 2x. And if it makes you feel any better, I just had to pause the video so I could go look up the cosine double angle formula. So I'm not really expecting you to memorize it either. But cosine of 2x is 2 cosine squared x minus 1, and that is over cosine squared x. So this simplifies nicely to just 2 minus 1 over cosine squared, which is actually just secant squared x. So the integral of this guy, 2 integrates to 2x, secant squared integrates to tangent. And you would not have been able to get that without your cosine double angle formula. All right, for number 11, let's see, pi integrates to just pi times x, and x to the 11th integrates to x to the 12th over 12. Don't forget your plus c. For 12, we're going to simplify this first. So 3x squared over x is 3x. Negative 4x over x is negative 4. 2 over x is 2x to the negative 1. Then let's integrate. So 3x goes to 3x squared over 2. Negative 4 goes to negative 4x. 2x to the negative 1 actually might have been easier to leave it as 2 over x and recognize it as the natural log. So it's going to be twice the natural log. Don't forget about the absolute values around your x, and then add the plus c. All right, for number 13, that's x to the negative 3/4. So when I add a degree, I go up to x to the 1/4, and when I divide by 1/4, I have a 4 in front, then I have a plus c. And then 14, you just have to memorize and recognize that this is the derivative of arcsine, so it integrates to the arcsine of x plus c.